Today we are going to discuss about register transfer and micro operations. In the very first lecture I informed you कि हमारे जितने भी प्रोग्राम्स हैं, जितनी भी इंस्ट्रक्शंस हैं, बेसिकली वो कहाँ पर पड़ी हैं? आपकी हार्ड डिस्क के और योर सेकेंडरी मेमोरी. Now what we need to do in order to execute these programs, we need to bring these programs into the main memory. So whatever program you have, a program means whatever instructions you have, whatever is the data that you have, everything is residing in the main memory. But we do not directly make execution in the main memory. Instead, we then bring all of the data in the next instruction. जो भी हमारी next instruction है उसके अंदर जो स्टेटमेंट दिया है उसको एग्जीक्यूट करने के लिए we bring that into the registers. What are the registers? Registers is a on board memory which is extremely fast, and we try our best that whatever computations we are going to perform, that should be performed while the data is residing inside the registers. I hope this little concept is understood, and that is why we are going to study what is the meaning of register transfer, micro operations, and what kind of register transfer language we use to denote the various operations. So this is the objective of this lecture today. So first of all, we need to understand what is the meaning of a micro operation. हम किस चीज को माइक्रो ऑपरेशन बोलते हैं? इट इज अ वेरी स्मॉल लिटिल डेफिनेशन, बट यस यू शुड नो it because it has an impact on other terms that we are going to study. So a digital module means computers are best defined by the registers they contain and the operations that are performed in the data stored in them. तो यहाँ पर क्या बात हो रही है? यहाँ पर बात हो रही है रजिस्टर्स की, रजिस्टर्स में पड़े डेटा की और उनके ऊपर परफॉर्म किए जाने वाले ऑपरेशंस की. सो वी आर टॉकिंग अबाउट दीज थ्री थिंग्स, राइट? So what is the definition of the micro operations? Very simple. The operations executed on the data stored in registers is called micro operation. So let us suppose if I say A is equals to B plus C, I have already informed you what is B and C. B and C are data variables that are stored in memory. And if I say add B comma C, अगर मैं B and C को ऐड कर रहा हूं तो डेफिनेटली द एडिशन ऑपरेशन विल बी परफॉर्म्ड ऑन B and C. But is it a micro operation? The answer is no, it is not a micro operation because B and C are residing in the memory and not in the registers. Then what is an example of a micro operation? I repeat again, if I have an operation like A is equals to B plus C, my first operation is move the B into register 1, move C into register 2, then perform addition on register 2 and register 1. So this is also the addition operation, but This is a micro operation because R2 and R1 both are registers. And by definition, what is a micro operation? An operation executed on the data stored in the registers is called the micro operation. I hope this very simple concept of what is a micro operation, what are registers, how we move the data from memory to registers, and how we perform the operations on the data residing in the registers. Okay, so with this we move forward after trying and understand what is a micro operation. Let's move further. The internal hardware organization of a digital computer is best defined by specifying. हमें तीन चीजों को स्पेसिफाई करना पड़ेगा if we want to actually discuss about the internal hardware organization of a computer system. So what are those three things? The set of registers it contains. जहां तक मैं बात कर रहा था R1, R2, these all are a kind of temporary या basic registers. इनका कोई ऑपरेशन नहीं होता है. These are used to store the data only, and they can be any number, R3, R4 तक, R5 तक हो सकते हैं. लेकिन आपके कंप्यूटर सिस्टम के अंदर कुछ स्पेसिफिक रजिस्टर्स भी होते हैं जिनका जो फंक्शन है वो ऑलरेडी डिफाइंड होता है. फॉर एग्जाम्पल AR will always stand for register. So we just need to understand what is the meaning of the first part. This is called the address register. So the meaning of the address register is that it is going to store the address of something. Then we can have like DR. D stands for data register. So what is the data register? It is going to fetch the data from the memory where the address register defines it. एड्रेस रजिस्टर ने कोई एड्रेस दिया है, उस मेमोरी लोकेशन पर जाना है, वहां से डेटा को फेच करना है डेटा रजिस्टर में. रीड करते समय, राइट करते समय जो भी एड्रेस रजिस्टर ने एड्रेस दिया है मेमोरी लोकेशन का, वहां पर जाकर डेटा लिखना है. कौन सा डेटा लिखना है? आपका जो वैल्यू डेटा रजिस्टर में दी है. देन वी हैव अनदर रजिस्टर कॉल्ड एक्यूमुलेटर. Accumulator is called the default register. There is no need to worry if you are not able to understand, because will discuss it again. Default register क्या होता है? मैंने मान लीजिए ऐड करने के लिए कहा A को. अब इंटरेस्टिंगली है कि add A, is this an incomplete instruction? क्या ये incomplete instruction है? A को किसके साथ ऐड करना है बताया नहीं गया है. तो इसका मतलब ये है कि वो कह रहा है कि एड ए, आई हैव नॉट स्पेसिफाइड एनीथिंग. इसका मतलब ये है कि आपको ए को एक्यूमुलेटर के साथ ऐड करना है बाय डिफॉल्ट. ठीक है. देन इसमें यह भी नहीं बताया गया है कि ऐड करने के बाद वेयर विल वी स्टोर द रिजल्ट. सो वेयर वी आर गोइंग टू स्टोर द रिजल्ट, दैट इज अगेन in the accumulator. That is why accumulator is called the default register. In case we are not specifying any register, then the computer system automatically picks up it to be the accumulator. तो सबसे पहली चीज जो इंटरनल ऑर्गेनाइजेशन में बताई जाती है, that is the set of registers that a computer system contains and the functions it can perform. The second is the sequence of micro operations performed on the binary information. What are the types of micro operations that we can perform? A couple of those micro operations I have already discussed, like add, move, and others that we will also see. The last is the control that initiates the sequence of micro operations. How we are going to initiate that micro operation, because you know that कोई भी ऑपरेशन विदाउट द सिग्नल, विदाउट द कंट्रोल सिग्नल दैट इज जनरेटेड बाय द कंट्रोल यूनिट, उसके बिना स्टार्ट नहीं हो सकता है. So it is possible to specify the sequence of micro operations in a computer by explaining each micro operations in the words. So आपको अगर कोई भी काम करना है तो उसकी सीक्वेंस ऑफ माइक्रो ऑपरेशंस जो है वो अवेलेबल है, आपको उसी सीक्वेंस के अंदर जाकर वो माइक्रो ऑपरेशंस को परफॉर्म करना है. The next is the most important term that we are going to study, because in this very unit what you will see is a set of symbols that we are going to use. Now what does those symbols denote? वो symbols क्या denote करते हैं, हमने उन चीज़ों को समझना है. So the topic that we are going to study right now is called the Register Transfer Language, which is also known as RTL. So it stands for Register Transfer Language, right? So the symbolic notation, ये एक symbolic notation होती है that is used to describe, यानी I repeat, first of all it is a symbolic represent notation. Symbolic का मतलब क्या है? Some kind of symbols will be used. ये किस चीज को डिफाइन करने के लिए यूज की जाती है? इट इज यूज टू डिस्क्राइब द माइक्रो ऑपरेशंस ट्रांसफर्स, यानी माइक्रो ऑपरेशंस को डिफाइन करने के लिए जो कि रजिस्टर्स के ऊपर परफॉर्म होते हैं, एंड ट्रांसफर ऑफ डेटा between registers. So that is what we call as a RTL. RTL stands for, like I have already said, it is a register transfer language. So what it will contain? It will contain a set of register names. It will contain a set of symbols that will define what we are supposed to do. Okay. So let's move even further. So how does a register transfer actually looks like? When I'm saying that I'm going to use the register transfer language, how does a register transfer looks like? Now, first of all, if I am talking about registers, first rule, like AR, DR, R1, R2, the first rule is that all of these registers should be mentioned in the capital. So that means you cannot write the register AR as this. You will always specify the register as AR in capital and not in small. So computer registers are designated by the capital letters. Okay. Sometimes followed by the numbers. What do you mean by sometimes followed by the numbers? Because if you are using temporary registers for data storing, then we can have registers which are numbered like this. Sometimes, not all. So when I am talking about address register, there is no need to number it. When I am talking about data register, there is no need to number it. But for temporary registers for storing the data, you can definitely number it. Okay. So what we have is computer registers that are designated by capital letters, then followed by some numbers to denote the functions. For example, the register that is used to hold an address in the memory unit is usually denoted as MAR, memory address register. You can see that it is written in the capital. ठीक है. Some of the other registers like PC, IR, then these are the temporary registers like R1. I have already explained what is an address register, what is an data register, what is an accumulator. Two more registers have come up, तो मैं आपको वो भी साथ में ही समझा देता हूँ, because then it will become easy for you to understand. One is called the program register, one is called the address register. मान के चलिए आपके पास कुछ इंस्ट्रक्शंस हैं, जैसे मूव करना है, फिर मूव करना है, फिर ऐड करना है, उसके बाद कंपेयर करना है. तो लेट अस सपोज दैट करंटली वी आर हियर and this is the next instruction to be executed. So the address of the next instruction, आपको जो next instruction execute करनी है, the address of the next instruction to be executed is contained in the special register called PC, that is called the program counter. And I hope that you all are noting it down, the type of registers that we are discussing. So address of the next instruction to be executed. जब हम इस इंस्ट्रक्शन को fetch कर लेंगे कि मतलब we have read this instruction, then the program counter will contain the address of the fourth instruction, because जो इंस्ट्रक्शन हमने फेच कर ली है अब उसका एड्रेस पीसी में नहीं होगा, उसके अंदर नेक्स्ट इंस्ट्रक्शन का एड्रेस ऑटोमेटिकली आ जाएगा। इसको हम लोग क्या बोलते हैं? इसको हम लोग बोलते हैं प्रोग्राम काउंटर इंक्रीमेंट। दैट मीन्स द program counter has been incremented and it now contains the address of the next instruction. Next is instruction register. Very simple. An instruction register will contain the instruction or instruction that we are going to execute. Now this will be very large in size, means larger than some of the other register, because an instruction will contain a lot of things in it. So basically what we are saying is that the instruction that we are going to execute, the actual instruction in execution will be stored inside the instruction register. Some of the registers that we have done so far is AR, DR, accumulator, program counter, instruction register, and temporary registers. I hope it is very clear. So let's move further. So when we are talking about designating registers, then we can also designate registers by specifying the, you can say, index numbers also. For example, if I say that the instruction register is of 16 bits, देन अगर हम कहते हैं कि इंस्ट्रक्शन रजिस्टर के फर्स्ट 3 बिट्स या लास्ट 3 बिट्स हमें कोई इंफॉर्मेशन स्पेसिफाई करते हैं, तो हम लोग इस तरह से लिख सकते हैं। व्हेन आई से सिंपली इंस्ट्रक्शन रजिस्टर, तो इसका मतलब क्या है? आई एम टॉकिंग अबाउट द ऑल इंफॉर्मेशन स्टोर्ड इन ऑल 16 बिट्स टुगेदर। लेकिन जब मैं कहता हूं इंस्ट्रक्शन रजिस्टर बट ब्रैकेट में लिखता हूं 14 to 16, that means I am only referring to the 3 bits, that is 14, 15 and 16, and I am ignoring the you can say first 13 you can say your values bits. थोड़ा सा यहाँ पर मिस्टेक है, that we cannot go up to 16, because if you have 16 bits then 16 bits are 0 to 15. We cannot go up to 16, तो यहाँ पर 14 to 15 कर देते। So these are 2 bits and these are 14 bits. I repeat, if there is any register which जिसका साइज जो है वो 16 बिट्स का है, देन द इंडेक्स नंबर और कैन बी मैक्सिमम फ्रॉम 0 to 15, राइट। तो मैंने अब आपको ये बताया है कि अगर आप पूरा का पूरा रजिस्टर रेफर करते हैं तो आप उसको आईआर लिख सकते हैं, अगर आप उसका पार्ट को रेफर करते हैं तो आप उसके बिट नंबर्स को स्पेसिफाई कर सकते हैं। सो लेट्स मूव इवन further your registers can be also divided into 2 parts. For example, if I have again a register which is of 16 bits, then the register can be divided into low and high. Low means the first 8 bits and high means the last 8 bits. For example 0 1 2 3 4 5 so on till 16. तो when I say दो पार्ट्स में डिवाइड कर दिया है, इसका मतलब 0 to 7 एंड दूसरा पार्ट क्या है 8 to 15, दैट इज लो एंड हाई. सो आई होप दिस इज ऑल्सो क्लियर. दैट मीन्स बार बार आपको रजिस्टर के साइज ना बताना पड़े. अगर आप फर्स्ट हाफ को उठा रहे हैं तो आपको 0 to 7 ना लिखना पड़े. उसके लिए वी हैव टू टर्म्स, वन इज कॉल्ड लो एंड वन इज कॉल्ड हाई. So this means the half of the register that I am referencing to. Okay, so if I am talking about the symbol PC 0 to 7, which means it is PC low. And if I am talking about the program counter 8 to 15, then that is called PC high. So this is I am hoping that this is also clear to you. So now let us see the very basic symbols and how we try and implement those, or how we interpret those. So the first statement that you can see in here is called R2, then an arrow R1. So what does this symbol representation do? R2 and R1. So the information, this particular one is an information transfer from one register to another register, ठीक है, in the symbolic forms by the means of replacement operator. Right. The statement R2 left side arrow with R1 denotes the transfer of contents of register R1 into the register R2. So that means we are copying the content of R1 into R2. It designates a replacement of the contents of R2. तो R2 के अंदर जो भी वैल्यू थी वो रिप्लेस हो जाएगी by the content of R1. A statement that specifies the register transfer implies that circuits are available from the outputs of the source register to the inputs of the destination register. So आपका जो सर्किट है वो तैयार हो चुका है. R1 से जो है वो आउटपुट जाएगी और R2 के इनपुट तक सर्किट तैयार हो चुका है. एंड आफ्टर द सर्किट इज रेडी द ट्रांसफर will be done. But we are not concerned too much about the circuit and other things because that will confuse you, and simply we are talking about this particular thing which says that we are going to transfer the contents of R1 into R2. Right. So now let us see how we can show this in the pictorial form. अगर मैं इस तरह से एक बॉक्स लगाता हूं जैसा आप रेक्टेंगल यहां पर देख पा रहे हैं और इसके अंदर R1 लिख रहा हूं, तो दिस इज सिंपली डेजिग्नेटिंग द रजिस्टर R1. और जहां पर मैं उसके इंडिविजुअल बिट्स को दिखाना चाहता हूं तो उस बॉक्स के अंदर मैं इस तरह से उसके इंडिविजुअल बिट्स को दिखा सकता हूं, starting from 0 up to 7, which means that the size of this register is 8 bits long. Right. So let's move even further. And this is how I can divide your register into two parts. On the left hand side, what you see is a register with the size of 16 bits starting from 0 to 15. And on the other side, I have pictorially shown you that your register can be divided into two parts. First part is 0 to 7 8 bits. The second part is 8 to 15 8 bits, and that is represented by PC low and PC high. What is PC? PC is a register called program counter. So what is the size? The size is 16 bits. Now, next kind of a symbol that we are going to see, this is controlled transfer. इसको हम लोग वो क्या बोलते हैं? इसको हम लोग बोलते हैं कंट्रोल्ड ट्रांसफर. जब मैं कहता हूं कि R2 को कॉपी कर दी, R1 के कंटेंट्स को कॉपी कर दीजिए R1 के अंदर, तो ये स्टेटमेंट को एग्जीक्यूट होना ही होना है. दिस स्टेटमेंट विल बी एग्जीक्यूटेड 100%. बट we want to put a condition to it. If that condition satisfies or that control signal is received, in fact not the condition, but if that control signal is received, then only we are going to execute the transfer. Then what we can use is we can use a concept called the control function. So what we are going to use? We are going to use the concept called control function. So let's see what is a control function. So without control function, if I want to simply say, I will say if P is equals to 1, if the control signal P is 1, then transfer the contents of R1 into R2. हमने पहले क्या लिखा था? सिंपली R1 के कंटेंट को R2 के अंदर कॉपी कर दीजिए. But now we have put up a conditions. If the control signal P is equals to 1, then only this transfer can happen. Now this particular statement can be written with the help of a control function, and that control function symbol is given in here. There is no need to write if P is equals to 1, then you can simply write P colon and then R2 with R1, where P is a control signal generated in the control section. So what is a control function? तो अब मैं आपको एक तीसरी डेफिनेशन देने जा रहा हूं, तो वो भी आप नोट कर सकते हैं. It is sometimes convenient to separate the control variables from the register transfer operation by specifying a control function. What is a control function? A control function is a Boolean variable that is either equal to 1 or 0. Right? The control function is included in the statement as follows. So what is a control function? It is simply a Boolean variable whose value can be 1 or 0. The control function or the control condition terminates with a colon. It symbolizes the requirement that the transfer operation, what is the transfer operation? R1 copied into R2 will be executed by the hardware only if the value of P is equal to 1. So I hope this particular notion is also clear to you, and what is a control function. In the exams, you can give a example like the earlier statement, how we write and how we write it with the help of a control function. So this is the symbol representation of the same. आप यहाँ पर एक सिंबल रिप्रेजेंटेशन कर सकते हैं. जो चीज नई आएगी वो मैं साथ साथ में आपको एक्सप्लेन करता रहूंगा. इसमें जो नई चीज आई है वो है एक कंट्रोल यूनिट, क्लॉक. So whatever operations that we perform, they are performed once the clock clicks or the clock moves. ये आप देख सकते हैं क्लॉक मूव हो रही है यहाँ यहाँ यहाँ. सो दिस इज द क्लॉक मूवमेंट दैट इज हैपनिंग, राइट. तो अगर मैं कुछ इंस्ट्रक्शंस लिखता हूं जैसे मूव मूव, लेट्स से ऐड, कंपेयर. So if all the instructions, let us suppose, require one clock cycle, तो जब एक क्लॉक मूव करती है या ट्रिगर करती है, तो जब फर्स्ट क्लॉक मूवमेंट आएगी तो ये इंस्ट्रक्शन चलेगी, सेकंड में ये चलेगी, थर्ड में ये चलेगी एंड फोर्थ पे ये चलेगी. और हर क्लॉक के साथ एक टाइमिंग लगी होगी कि एट व्हाट टाइम द एक्चुअल इंस्ट्रक्शन विल बी एग्जीक्यूटेड, राइट. तो यहां पर आप देख सकते हैं what does this symbol designate. So if I look at this image very carefully on the top, it says that the control circuit should have P is equals to 1. P की वैल्यू जो है वो 1 होनी चाहिए. Just give me some time for you to explain this in an even better manner. So I repeat, let us continue. So the control signal circuit should generate P. Only when the load circuit will generate P, then the load operation will happen. So when I say R2, R1 content should be copied into R1. This is known as the load operation. Load the contents of R1 into R2. So what does N suggest here? Students, please note and remember these things. They are easy when I am speaking, but they are very difficult when you will read. N means N number of bits will be loaded. So this P means the value of P should be 1. Then the load operation will be performed and N bits will be transferred from R1 to R2 when the clock clicks. तो आप यहाँ पर देख सकते हैं the clock is moving and when the time is t, जब जैसे ही time t हुआ, so that means the load operation has to be performed and the load pulse is set to high. That means the load operation has started. At time t plus 1, the load operation is complete. मैं आपको दोबारा रिपीट करना चाहता हूं, t पर लोड ऑपरेशन स्टार्ट हो रहा है, t1 प्लस 1 पे लोड ऑपरेशन कंप्लीट हो रहा है. सो जैसे ही ये कंप्लीट होता है, देन इट इज यू कैन से सेट टू लो एंड द ट्रांसफर एज एक्चुअली हैपेंड हियर. यहाँ पर आपका ट्रांसफर जो है वो परफॉर्म हो चुका है. ठीक है, these things are for your knowledge, not directly specified in your syllabus, but you should know that. This is a complete example of how the transfer actually takes place. The statement 1 is specifying the if then symbol, control symbol, then it is shown as a control function. Then the figure gives you an example of how this operation is actually being performed, and rest everything is an example, the explanation of what I have explained to you. You are requested to kindly go through this. I will share these with you immediately after the lecture. So now again, there is one more thing that has been specified in here. So I'm not saying that this is what is going to happen, but there is a possibility that two or more micro operations, two or more micro operations can be executed at same time. So how we designate those? We designate those by separating them using the comma. तो ये स्टेटमेंट एक्चुअली में क्या बता रही है? दिस इज माइक्रो ऑपरेशन नंबर 1, दिस इज माइक्रो ऑपरेशन नंबर 2 and they both will be executed at the same time t. So the arrows denotes the transfer of information. A comma is used to separate two or more operations that will be executed at the same time. So I hope this particular notation is also clear to you, which is denoting more than one operation at the same time. And this is our last figure that we are going to see, because this is what we have studied and we are just trying to recap what has happened. Okay, so what does the letters and the numerals denote? They denote the registers. For example, R2 is a register with a numeral MAR. Then you can have DR, you can have PC, you can have instruction register, and so many. What does the parenthesis, the brackets show? They show the denote the part of a register. यानी अगर आप सिंबल्स नंबर ऑफ बिट्स बता रहे हैं, R2 I am picking up the bits from 0 to 7 which is equivalent to R2 of L, low. What does the arrow denote? arrow denotes the transfer of information, and here R2, then symbol on the left side R1 denotes that the information is being transferred from R1 to R2. And the last we saw was comma. The comma is separation between two micro operations at the same time. So these are happening at the same time. So when I say that R2 with R1 and R1 to R2, these are two micro operations at different times. This can be at T0 and this can be at T1. But when I say T1, R2 with R1 and R1 with R2, this means these two micro operations are happening at the same time. So this is same time, this is at different time. So with this we come to the end of this lecture. uh, like I've already said, that in case if you have any questions, you can ask me, or you can ask me at the start of the next lecture. So I am waiting. If you have any questions to ask me, you can type those questions. Otherwise you can simply type no. डेटा रजिस्टर इज नथिंग. जब आप एक मेमोरी की बात कर रहे हैं कि मेरी कंप्यूटर मेमोरी है, उस मेमोरी के अंदर एक्चुअली में डेटा पड़ा है, तो आपने पहले एड्रेस रजिस्टर को उठाया. एड्रेस रजिस्टर ने कहा मेमोरी लोकेशन 89, तो मैं 89th मेमोरी लोकेशन पर जाऊंगा. वहां पर जो भी वैल्यू पड़ी होगी उसको कॉपी करके अपने डेटा रजिस्टर के अंदर ले आऊंगा. तो डेटा रजिस्टर एक्चुअली कंटेन्स द रियल डेटा. Instruction will contain the whole of the instruction, comprehensive instruction, whereas data register will contain only the data. So if you have further questions, you can ask me in the next lecture. The timing of this lecture is getting over. So please read these notes. I am going to share these notes immediately right now.